There we go. So today we're talking about 7.3, which has to do with what we call measures of central tendency. So this is mean, median, and mode. And then we're talking about creating box and whisker plots. So I am just going to get right into it, okay? Let me share my screen. All right. All right, so you can see that two important aspects of data are its center and its spread. The mean and median are measures of central tendency to describe where the data is centered. So the mean is commonly referred to as the average value and is found by taking the sum of all the values in a set of data and dividing it by the total number of values in the set of data. So one of the things that you would see as the definition is, you'll see it as the sum of n over n equals x bar, or excuse me, not the sum of n, but you'll see it as the sum of x I over n equals x bar, which is a really weird way of just saying that you're going to add up the values. If you have n of them, meaning some random value, and then you divide by how many you have. So again, I don't really care that you know what this really means. I just want you to know that if you see it in your textbook, that's what they're talking about. All they're trying to say is the sum. So that big E is the sum notation. So the sum of all the values divided by how many there are. And the X bar is referred to as the mean. So the median is the middle value in a sorted data set, or the average of the two middle values if the number of values is even. To find the median for a set of numbers, first arrange the numbers in order from least to greatest, and then find the middle number. If n is odd, the median is the middle number. However, if n is even, the median is the mean or average of the two middle numbers. So remember, n is just saying if we have n number, right? So let's say n equals 3, then it's the middle number. If n equals 4, then you would add numbers 2 and 3 and then divide. So what does that look like? So before I talk about mode and range and all that business, let's just first try finding the mean and median. So in our example here, we've got our set. If we count how many we have 1, 2, 3, 4, 5, 6 numbers. Okay, so we're going to find our mean first. So we're going to add these all up. And then we're going to divide by 6 because there are 6 numbers total. So go ahead and simplify that and send me your answer in a direct message. Okay, so if we add them all up, the numerator ends up becoming 480. We divide by 6, that gives us a mean of 80. The median, so we've got 60, 60, 70, 95, 95, 100. So there are 6 values. So that means the median is here in between the set. So we've got 3 on each side. So that means we need to find the average of those 2 values in order to identify the median. So I'm going to take 70 plus 95 and divide by 2. So 70 plus 95 is 165. Divided by 2. And we get 82.5, and we do not want to round this. Okay, you want to leave it as it is. Therefore, the median is 82.5. So you'll notice both the mean and median can be values that aren't even listed in the set of data, because the mean is the average of all of them, and the median is what that middle value would be. Obviously, if there's 2 middle values, we have to average them and find that. Finally, the mode is the most common value or values, if there's more than one, that occurs with the same frequency in a distribution. If there is no specific value that occurs more frequently in the data set, then the set does not have a mode. So when we look at our data, the number 60 occurs twice and the number 95 occurs twice. Therefore, this is considered bimodal because there's 2 of them, and the modes are both 60 and 95 because there's 2 values that occur with the same frequency, more than the rest of the numbers. Again, if every number had only occurred once, then there wouldn't be a mode. Okay, because there's no values that occur more frequent than the other ones. Because there's 2 that occur twice and other numbers could occur only once, that creates the mode situation. So questions about mean, median, and mode before we go to our second example. So just some additional terminology. The range. So first of all, mean, median, and mode are all measures of central tendency, meaning they measure how the data is centered. But then you have the range, and then something called the interquartile range, the variance, the mean absolute deviation, and the standard deviation. We're going to talk about all of these values later. We're not talking about those right now. Okay. We are going to talk about the range, which is the difference between the highest and the lowest values in a set of data. So if we were going to find the range for this set, I would take 100 minus 60, which would give me 40. There's a 40 point range between those, right? Because the highest is 100, the lowest is 60, so there's 40 values within there. The interquartile range we'll talk about later when we get into the box and whisker plot section of the work. So I want you to think about what we did in number 1, and I want you to find the mean, the median, and the mode. So unfortunately for the median, these are not in numerical order, so you'll have to put them in numerical order. Okay, so the mean, we add them all up, we get, I'm not gonna bore you with doing the math because we get 0.919 for the mean. One thing to keep in mind in terms of monitoring your answers and figuring out, is this a feasible answer or not? Your mean is never going to be greater than the values that you are given, right? So like if you were to add them up, or like substantially lower. So if somehow you added them up and you divided by the wrong amount and you got like 0.5 as your mean, that's not going to work because all of your values are between 0.8 and not even quite 1, right? So it has to be somewhere in there when we're averaging them, much like it can't be greater than like 0.9 something, because again, we don't have any values that go up to 1. So we wouldn't have a mean that's over 1. So the median, we have 11 values here. So if we write them out, this is the fun part, right? I like to cross them off as I'm going, so I don't miss one. Okay, so we count, there's 11 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we go 5 in on each side, we're gonna have the sixth number, 0.920 as our median. And then our mode, there isn't a value that occurs most frequently, so we would say none. How many of you have a graphing calculator? You just wanna, if it's a yay, you do, okay. You don't, if you don't, that's totally fine. I was just going to show you a quick way that you can do this on your graphing calculator in order to find it. But it looks like only one of us, 2 of us. Okay, well, I'll show you quickly. For those of you who do not, if you have a smartphone, then there is a free app that you can download, and it's called Wabbit Emu. And it is a graphing calculator emulator. And we're like, what does that even mean? It's it looks like a graphing calculator, but it's on your cell phone. And so you can use all the buttons and the functions and everything. And so if you were to use it in another class and you weren't allowed a cell phone during your lecture or during your test, that's where it wouldn't be helpful. But obviously on your homework, it is helpful. So in order to get to it, let me do a new share. Hold on 1 second. Okay, so here is the graphing calculator. So what I want to do is I'm going to enter this set of data into my calculator. So in order to do that, let's see if I can make this bigger. Okay, so we want to get into we're going to press stat, which is here. And if you want to like go back and watch this video again, that's totally fine. So we're going to press stat and see where it says edit. We want that because we're going to enter a list of values. So I'm going to press enter. Now, sometimes it comes up with values in here. Mine comes up because I've used it. If it's your first time using it, this won't happen. To clear those out, you would press the up key and then clear. And then we would go and press enter. And then you go to the left, press up, press clear, press enter. So at this point, this is where you want to enter your data points. And then as you're entering them, you would just press enter to go down. The nice thing about using this is that you do not have to have them in order to be able to find these. Okay, so I've got all my data points entered. And so I'm going to get out of this window. So see how the word quit is in yellow? In order to get to it, that means you have to press this yellow second key. They go together. I'm going to press second and then quit. And now I need to go back in and run some tests. So I'm going to do second, and then I want this list. So in order to get that, I'm going to press the stat key after I press the second key. And then I'm going to go to the right to math. And you'll notice here we've got mean and median. So the nice thing about this is that it will find your mean and your median for you. So we're going to go down to mean and press enter. And we need to run it on list 1 because that's where our stuff is located. So to get to list 1, you'll notice right here it says L1 with the number 1 key. Again, that L1 is in yellow. For some of you, the second key might be blue on your graphing calculator. And so we would press second and then L1, end our parenthesis, and press enter. And you see it comes back with that 0.919, blah, blah, blah. I keep the number of data points that's equivalent to what everything was to begin with. So you notice all of those original numbers were to 3 decimal places. So I rounded our mean to 3 decimal places. Now to get to the median, again, we repeat our steps of going into this list menu. So we press second, stat, go over to math, go down to median, and press enter. Now to get that L1 again, we're going to press second and then the number 1 in parentheses, and we get 0.92. The only problem is that good old calculator won't find our modes for us. You got to do that visually, unfortunately, but it will find the mean and the median for you. So if you have access to a graphing calculator or you have access to that smartphone app, you would be able to find those that way instead of having to do it all by hand. On the exam, when it comes time, I'm not going to give you a crazy amount of data to find the mean and median for, because again, I'm going to expect most of you to be doing this with just like a normal calculator, and that I don't want to make it harder for you. So let's go to the next page. Go back to that bad boy. And so blood alcohol concentrations of drivers involved in fatal crashes, and this data came from the U.S. Department of Justice. I want you to find the mean, the median, and the mode for this set of data. The mean is going to come out with a number that when you find it goes to 4 decimal places. Leave it at 4 decimal places because it terminates. So remember, in order to find the median, you have to first list your values from least to greatest. So if we don't do that, then we'll end up with a weird value. But for our mean, we get 0.1875. I would leave it, if it terminates, I would leave the full number unless the instructions tell you to round to a specific place value, okay? Then your median is 0.165 and our mode is going to be 0.16. We've got 1, 2, 3 of them, right? So any questions about those? So if we list these out, how many values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have an even number, which means we're going to have to average two together. So we need to make sure that we list them from least to greatest. So we're going to start with the 0.12 and then 0.13, 0.14. And then we have to list all three of the 0.16s. We can't just list one of them. And then we've got 2.17s. And then what do we have left? 0.24s. and then a 0.27 and a 0.29, right? So we're looking for, because we have 12 values, we're going to go to the middle. So we're going to go 1, 2, 3, 4, 5, 6. And so it's going to have to live in here between the two middle numbers in the data set, right? Because if we count from either end, 1, 2, 3, 4, 5, 6, there's a 6 number. And from the other side, 1, 2, 3, 4, 5, 6. So there's two even ones. So I'm going to do 0.16 plus 0.17, and then divide that value by 2, which is going to give us the 0.165, which is how we get to that middle number. Okay, so the mid-range is the value halfway between the highest and lowest values in the data set. So the mid-range is sort of like the median sometimes, and then other times it would be a value that's not even there, because you take the lowest value and the highest value, you add them together and divide by 2. I will tell you, I have never used the mid-range for anything, but it is one of your vocab values, or words, so I just want to talk about it. So its usefulness as a measure of center can be compromised if there's an outlier, much like the mean can be compromised by an outlier as well. And then, so a outlier is known as a value that's either much higher or much lower than your overall set of data. Although the mean is most commonly used average to describe a set of data, it might not always be the appropriate choice. So number 1 says, suppose a company employs 20 people. The president of the company earns $200,000. The vice president earns $75,000. And 18 employees each earn $10,000. Is the mean the best number to choose to represent the average salary of the company? So I don't want to waste your time by listing out 18 10,000 values, right? So if we think about finding the mean, our numerator is going to be 20,000 plus 75,000 plus 18 times 10,000, because we have 18 of those values. So instead of listing out all 18 of the 10,000s, we can simplify that by doing 18 times 10,000. And then since there's 20 people, there's the president, the vice president, plus all the 18 other people. That means we would divide by 20. So go ahead and finish that. Remember, simplify your numerator before you divide, and let me know what you get. So if we add this all up and divide by 20, we end up with $22,750 as the mean, right? This is the mean salary. So is that a good representation of the average salary of any of the workers? What do we think? What do the predominant number of people at this company earn? They earn 10,000, right? So telling one of those workers that the average salary at the company is 22,000, they're going to look at you and be like, since when? I'm not getting that, right? They're going to be upset. So if we look at this, if we were to find the median in the mode, they're both going to be $10,000. So those would be better measures to talk about the overall average of the income at this company. And when we talk about outliers, the president's salary and the vice president's salary, those would be considered outliers because they're so far beyond what the set of data really is. And they're really skewing that mean up from what it really should be. So then, suppose the 9 students make the following test scores. Is the median the best average to represent the set of scores? What about the mean and the mode? So I want you to go ahead and find the mean, median, and mode and tell me what you think would be the better number to represent this set of data. If there is a good one, if not, tell me that too. Okay, so the mean for this, we add them all up and divide, we end up with 68.7 repeating or approximately 68.8. The median, since there's 9 values, we don't have to average any. And so the median is going to be a 92, and then the mode is 40. So looking at these scores, it's kind of a crazy set of data, right? If we were to graph it, we'd have a whole bunch on the high end and a whole bunch on the low end, and there's like nothing in between, right? So the mean is a better representation of the data. This is actually bimodal data. Sorry, there's a mode of 40 and a mode of 92, because there's 2 values that occur twice. And so really none of them are very good representations, because it's not showing how the class did as a whole. It's either they did super well or they failed, right? There's no in between. And so all 3 measures of central tendency are kind of misleading. The mean is kind of closest, but even then it's not great. So it's a rough one. All right, let's talk about box and whisker plots. So how do you create a box plot? So a box plot is a visual representation of your data. That's how you want to think about it. So you first want to order your data from least to greatest. You want to identify the upper and lower extremes, or the min and max. These are the highest values. You want to find the median for the data, and we mark this as Q sub 2. Okay, so you can see in my diagram, I've got Q sub 2 marked in the median. Then you're going to split your data in half, excluding the median. This creates 2 quartiles. So we've got the lower quartile and the upper quartile. So the lower and upper quartile, you're going to find the median for each quartile. So this would be considered, like if you had your data, there's your lower and there's your upper, right? And then you find your median. Of each. And then you create a number line, and that will allow for the upper and lower extremes to fit. Make sure your number line has uniform ticks on it. So like you're going by 5s or by 10s or whatever makes sense for your data. And so above the number line, you're going to mark the minimum point, the maximum point, the median, the lower quartile, and the upper quartile. Then you're going to draw vertical lines through those dots for the median, the lower quartile, and the upper quartile. You connect the vertical lines to form a box, and then you draw lines out to your whiskers. So if I were to graph this data, here's my number line. Here's my median. Here's my quartile 1. Here's my quartile 3. Here's my min. And here's my max. So I draw vertical lines through these values, and I connect them with a box, and then I draw the whiskers out to the min and max. So one piece that I don't have on here is that you need to identify the interquartile range. And the interquartile range is Q Q3 minus Q1. And the reason why we want to find this is that it helps us to identify any outliers. Okay. So the only way to really get into this is to practice it. So we've got this set of data. I've already put it in numerical order for us. So it's going from least to greatest. If we count our data, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So we've got an even number. We're going to go in 1, 2, 3, 4, 5 on each side, which means our median has to be between those, right? So if we look at our steps, the steps say order your data. We already did that. Identify the upper and lower extreme. So the lowest or the min in our data range is 20. The max is 35, right? There's the min and there's the max. Then it says find the median of the data and mark it as Q1. So the median is going to be 26 plus 27 divided by 2, which gives us 26.5. Then it says split your data in half, excluding the median. So my median is right here in between. So if I split my data in half, I'm looking at that set of data and that set of data. So we find the median for each of those. So the median of the lower quartile, or Q1. So I'm looking here, I've got 5 data points. So there's my median. And then we find the median of the upper quartile, which we mark Q3. So again, looking at this, I find my middle number, which is 28. And that's my value. So why are we doing all this? What is this helping us? Again, box and whisker plots are a visual representation of what your data is doing. Okay, it's hard to see how it's spread about when it's just in the list. So we're going to create a number line. And I'm going to go by 2s. And again, you can go by whatever you want. Like, you just have to be consistent. Okay. And you don't have to draw like from 0, right? We're just showing that this is our data range over here. Okay. So again, we're going to start by marking our minimum value. So there's my minimum. And my maximum value is 35. So it's going to be right here in between. Then I'm going to mark my median, which was 26.5. So that's right here, and we're going to draw a vertical line. Again, this is my median. Then I need to draw my Q1 and Q3. So Q1 is the median of the lower quartile, so 22. We draw a vertical line. And Q3 is 28. And we draw a vertical line. So we now connect these and we draw our whiskers. So what is this telling us? Well, the upper set of data is more close together, which is why that box is smaller. The lower set of numbers, so from 20 to 26, is more spread out, which is why we have a bigger box there. Okay, there's more of the, there's more data points there. Because there's a bigger difference from 22 to 25, where on the other side, we're going 27, 28, right? They're closer together. And so it's showing you how that data spreads. So again, this is my lower, this is my upper, this is Q1, Q2, which is the median, and then Q3. Now, like I said, you want to identify your interquartile range, or the IQR. And our IQR is your upper quartile minus your lower quartile, or Q3 minus Q1. Q3 was 28, Q1 is 22. And if you think back, have we not talked about it? I guess we haven't talked about it yet. So we're going to talk about it on the next page. But in order for a data point to be considered an outlier, it needs to be more than 1.5 times the interquartile range away from the median. Craziness, right? So we would then check that, which we're going to have to do on, it's 1.5 times above the upper quartile or below the lower quartile. For us in this data set, we don't have an outlier. In our next data set, we do. Okay. So it's good to just check this. Again, 1.5 times 6 is going to be, what is it, 9, I think? And so the Q3 is 28. If I take 28 and I add 9 to it, I get 37. And so all of our data is less than 37. So we don't need to worry about there being an upper outlier. And on the other side, if I take 22 and I minus 9 from it, I get 13, which again, all the data is above 13. So we don't have to worry about any outliers in this set of data. In the next set, we do. So before I move forward, I just want to make sure if there are any questions about creating box and whisker plots. It just takes practice. We'll do more of them, okay? So like I said, outliers. An outlier is a value that is widely separated from the rest of a group of data. In the set of scores 91, 92, 92, 93, 93, 93, 94, all the data are grouped closely together and no values are widely separated. However, if we were to take that same set of data and add the numbers 21 and 150 to it, both 21 and 150 are way far away from that central mass of data, and therefore they would be potential outliers. So how do you identify outliers? An outlier is any value that is more than 1.5 times the interquartile range. So remember IQR. Which we find by taking Q3 minus Q1, okay? Has to be 1.5 times, so it's that value above the quartile, the upper quartile, or below the lower quartile. The outliers are commonly marked with an asterisk, and whiskers are then drawn to the extreme points that are not considered outliers. So I'm going to go through that in this next example. So I've initially said that these were the top final medal standings for the 2022, and these are Summer Olympics. It was the 2020 Summer Olympics. I checked this data yesterday and then I forgot to adjust it because they didn't have enough for the Winter Olympics. And then I didn't include 20, I included 18. I don't know what I was doing, it was all over the place. But so the United States, we ended up with a full, like our total medal count was 113 medals. China had 88. ROC is the the Russian Olympic Committee. They had 71. Great Britain, blah, 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 all the way down to Poland, who had 14. So do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be an outlier here? Do you think there's going to be We're going from 113 down to 14. So as we look through, I mean, a lot of this data is pretty close together, right? From 40 to 14, there's not that much spread, but so that 113 could be a potential outlier that we're going to have to check. So we need to identify our min, our max, our median, our quartile 1, and our quartile 3. So I want you to start by doing that. If you need me to show you the example from the previous page, let me know. You don't have to send me all that data. You can just identify them on your paper, and I'll just give everybody a little bit of time to figure it out. Okay, so our minimum amount is 14 and our max is 113, right? Those we're pretty comfortable with. Now we have 18 values, so we have an even number of values, so we're gonna have to find the middle of the median. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, we're looking for the middle between 36 and 33. So the median, I'm going to take 36 plus 33 and divide by 2. And we get 34.5. So Q1 is the median of the lower quartile. So the lower quartile is these numbers right here, right? So if we count those, whoops, we got to include 33 in it. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have an odd number, so there will be a nice middle number. Counting 4, 1, 2, 3, 4. The fifth number, 20, is going to be that median. Finding the median of the upper quartile. That's going to be these numbers. So again, 1, 2, 3, 4. We end up with 58 as that value. So let's graph our initial stuff, okay? I'm going to go by tens. Okay. So we're going to put arrows on the ends of our number line so we show that it's extending off in a different direction. So our median of 34.5 is going to be about right here. Our min of 14 is right about here. Our maximum of 113 is up here. Our quartile 1 is 20 and our quartile 3 is 58. So looking at this, I'm not drawing any whiskers yet because we need to think about the fact that could we have an outlier? Just looking at, look how far 113 is outside of our box. The box represents the middle 50% of data, okay? So that is our middle set of data. That is what most of it is, okay? So in order to identify, do we have an outlier? So in order to identify that, we first need to find the IQR. So remember the IQR is Q3 minus Q1. So we're going to do 58 minus 20, which is 38. So now we're going to do 1.5 times 38. Which gives us 57, okay? So in order to identify if we have an outlier, it's 1.5 times the interquartile range above the upper quartile and below the lower quartile. So the upper quartile ends at 58. So we're going to do 58 plus 57, which gives us 115. So if we had an outlier, it would have to be 115 or greater. We don't have one. So this is still considered within the set of data. A lower mount, so this would be the upper, the lower would be 20 minus 57, which would be negative 37. So it would have to be numbers less than negative 37, and clearly we don't have that. 1.5 comes from just the definition. So it is just the definition of outliers. Later, when we get into standard deviation, it's a number that's 3 standard deviations above and below the mean. But right now for our box plots, we're just using the definition of 1.5. And so you'll find that in this text box right up here. There's that 1.5. So an outlier, again, is any value that's more than 1.5 times the IQR above the upper quartile or below the lower quartile. So because we don't have any outliers, we don't have to worry, but what conclusions can we draw from this data? We can see that 50% of the data is very closely grouped together, right? Most of our countries did not earn over 35 medals, right, total. Because again, this is 50% of the data, right? This is also 50% of the data. Therefore, there is a huge difference in the upper limits of our data versus the lower. So the first 50, much closely grouped, the upper 50, huge range there, right? So the last thing, you know, I'm going to leave that until there's just like one more slide or one more page I have here that's talking about comparing box plots. And so I want to add on to that from Tuesday's lecture, because we went through most of box plot stuff today. And so if you look at our schedule on 412, we're supposed to continue for 7.3 and then look at box plots, because margin of error got put on the schedule wrong. We're not doing that till later. And so we have some more time to go over these. So I want to look at how do we compare these values to each other, okay? And so so I'm going to keep this last slide here, the last piece of your notebook, till Tuesday when we talk then, okay? So just to reiterate, let's not forget, your test is due tonight. If you have not done it, please do it. You have 11:59 p.m. at the latest. Good luck. Any questions for me before we go?
I have a question on the 7.2 homework. I think, so do we do question number 3? Because you put a note like do, 2 graphs, or I don't remember quite what it said, but in like just the regular problems, you just did like 2,4, like you didn't include 3. So I was just curious.
Don't do 3 then.
Okay, because you did put what to do on there. I just wasn't sure.
Yeah, I can't, I'm trying to find my lecture notes from then. My stuff got all mixed up and it's not directly in front of me. I apologize. Oh, there it is. Okay. What did I write? I wrote.
Unless I just totally read it wrong. I don't know. I could have.
Yeah. I wrote 7.2, 2, 4, 8. So don't do 3, don't do 5. Right? On
okay,
number 2. Oh, go ahead.
Sorry. In the content, you put like on number 3, do these 2 graphs. Okay.
Yeah, so on number 2, I want you to represent the data using a line graph and a bar graph. And then on number 4, you're going to represent the data in a graph, one that minimizes the differences and one that maximizes. And so my hint to you is think about adjusting your vertical scale.
Oh, I thought that note was on number 3. Because in the, hold on, I'm trying to look for it.
Very well that I could have typed it wrong, and I didn't mean to.
Okay, yeah, because in the content, it says on number 3, draw 2 graphs, one that minimizes the differences and one that maximizes it. But that's for number 4.
Yep. So
Okay,
let me
cool.
fix that really fast while we're all here together. And what happened there is I see how it says $3. I was trying to do the number sign and then 4, and I just hit the 3 button twice. So
Oh, gotcha. Okay, thank you.
yeah. So there you go. So yes, do 2 and 4. And then there's also an assignment in there for 7.3. I won't go over it though yet until we finish up on Tuesday. So don't stress about that. You've got till next week to do that one, okay? All right, everyone. Don't forget 7.1 and 7.2 are due tomorrow night. And your test is due tonight, okay? All right, I hope you all have a good day and I will see you next week. Bye, everyone.